Hello, my name is Dan. I'm a tutor at King University's Tutoring and Learning Support Services. Today I want to talk to you about some statistical measures. Statistics and probability is one of the courses I tutor most often, so I thought it would help to put an introduction to some of those topics on a video for you guys so that you can access it when I'm not around. So we're going to use a card deck to do what I like to call card deck probability. Basically, we're just going to do some odds versus probability using a standard deck of cards. These here are the jokers. I'm taking them out because they kind of complicate the measure, but this is just a regular deck of playing cards. And a regular deck of cards is set up in a pretty specific manner. And so for those of you who aren't familiar, there are 4 suits in a deck of cards. You got diamonds, which have the diamond on them. This shape here, that's called a spade. You have clubs, and then you have hearts. Right. So if you noticed, 2 of those suits are red, and 2 of those suits are black. Yeah. And each suit is comprised of the same cards. So every suit has 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we get into face cards, which are Jack, Queen, King, and Ace. So let me just show you those face cards. So that's a King, that's a Jack, that's a Queen, and that's an Ace. Alright, so that's the basic rules of the deck of cards. And let's get into some measures of probability. Okay, so I'm going to move the view so that you guys can see exactly what it is that I'm doing with the cards. I have it set up a little bit so I can show you specific examples. Right. So the first thing I'm going to do is just draw the top card, and we'll talk about what are the chances that the top card is the top card. Right. King of Spades. So there is only one King of Spades in the whole deck. There are multiple kings, but only one King of Spades, right? Because there's each suit only has one king, and we have 52 cards in the whole deck. So if we're talking about odds are represented as the chances of yes and the chances of no. So we have 1 chance of yes to 51 chances of no. Versus probability is part to whole, talk about it as a percentage. So we have 1 out of 52 here. 1 out of 52 is your probability. It's going to be a little less than 2%. You have a less than 2% probability of pulling a king out of this deck, a King of Spades out of this deck. Now, if we expand that and we say, what are the chances that I pull a king? The odds that I pull a king now become 4 to 48, and odds you reduce just like a fraction. So 4 to 48 is 1 to 12. So there's the odds of me pulling the king are 1 to 12. So now, if you're looking at odds, the nice thing is you can figure out what that total is by adding the 2, right? Because we have yeses and nos, but yes and no together equal everything. So the chances of me bringing the king to 1 to 12 means it was 13 total. So that's what the reduced subset is. But remember, it was really 4 and 48, which gives you the 52. So if you're talking about probability, you have to count for everything when you add those numbers. I'm sorry, when you're talking about odds, you count for everything. When you talk about probability, everything's already accounted for in the base, because remember, it's part of the whole. We do count everything as one group then. So that 4 out of 52, which is 1 out of 13, and 1 out of 13 is 7.7%, right? So you just divide 1 by 13, it gives you 0.0769. I rounded that up, and then multiply by 100 to get 7.7%, just in case anyone's not familiar. I do have it on the board here too. So odds 1 to 12, so it's yes to no, and then with probability, it's the event versus the total possibility of events. which want to be 1 to 13. 1 over 13 equals 0.077 equals 7.7%. Okay, back to the cards. So let's talk about the kings as a subset of themselves. I have 4 cards here, right? So if I say, what are the chances I draw a red card? So 2 out of 4. The chances, as far as odds go, is 1 to 1, right? So it's 2 to 2, but that reduces to 1 to 1. So I have equal opportunity to succeed as to fail. If I say, what are the chances I draw a king? As far as odds, it's 1 to 0. I can't not draw a king. There is nothing other than a king here, right? Those are great odds. You ever see a game that works that way for you, definitely play it. However, conversely, if I say, what are the odds I draw a 2? That's not possible. It's 0 to 4, because there are no 2s. What are the chances that I draw, well, let's see, let's do a different subset, because I think that covers that pretty well. Right, probability on this is going to, the probability I draw a king from this is 4 out of 4, which is 100% probability. Right, the probability I draw a red king is going to be 2 out of 4, which is 50%. The probability I draw the king of hearts or the king of spades or any one of these specific cards is going to be 1 out of 4, which is 25% this probability. Right. So now I'm going to shuffle, and I'm going to do a random set of cards, and we'll talk about how this works when we're not talking about a whole huge set. Right? You'll actually get to see everything here. Alright, so you can see all the cards. Got 4. Oh no, we're supposed to have 10. One more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so we have 10 cards here. And you see, actually, some of them doubled up. A few of them doubled up, some of them didn't. I have at least one of each color. I think I have one of each suit. So there's like a fair random representation of what goes on in a deck of cards here. Right, so we're going to say, what are the odds from this? We're going to pretend the rest of the deck doesn't exist. It's just these. This is our total population, right? What are the chances that I draw a 2 out of this? So we only have 1, 2. So I could say the chances, the odds I draw a 2 or the odds I draw a 2 of club, it doesn't change because there's only the 1, 2 here. I don't have others to worry about distinguishing. So the odds I draw a 2 are 1 out of 9, or 1, 2, 9. You always say odds and yes, 2, no. So 1, 2, 9. Probability is 1 out of 10. Right? I have 10 total, which is 10%. Let's see. So I can say, what is, let me do something else for you too while we're here. So we're talking about probability. When I know the probability of something happening, I also know the probability of something not happening, because probability is always out of 100%. So if I say that the probability of drawing a 2 is 10%, then the probability of not drawing a 2, right? So we have 9 things that are not a 2 and 10 cards total, so it's 9 over 10 is 90%. Now if you notice, if I add the probability of the chance of that happening, the probability of it not happening, I get 100%, which always has to happen when you're talking about a population. You have to be dealing with it in its totality, so there's always 100%. So if you're talking about percentage, you do 100 minus the probability of yes to find out the probability of no. If you're talking about it as a decimal, so this is going to be 0.1, so you do 1 minus 0.1 gives you 0.9 if you're dealing with probability in decimal form. Okay, so how about if we do something where there's more options? So the odds that I draw a 6 from this deck right now are 2 to 8, which is 1 to 4, so I have 1 to 4 odds of drawing a 6. My probability is 2 out of 10, so 20% chance that I draw a 6. Same thing holds true for, let's see, I like this because this one we have different colors. So I say the probability of drawing a queen is 2. It was the same with the 6s. So we've got 2 to 8, which is 1 to 4. The odds are 1 to 4. The probability is 20%. But now, what if I say, what are the odds of me drawing the black queen, right? So then that changes. It's 1 to 9 and 10%. So I hope that at least helps you start. We're going to do some more videos on this. I'm going to get into more stuff with subsets, and then compounding probability, where if we take the set and I draw a card, I say the first card we drew was the queen, and now we're doing another problem with that same subset without replacing this. So if that's your question, look for future videos, and I really hope this helped. Like I said, my name is Dan. Look forward to seeing you again. Thanks.